Alright, so in this problem, in a bacterial culture, the number B of bacteria presented is modeled by B equals 15,000 e to the 0.3 times t, where t represents time in hours since 12 noon. So how many bacteria will be present at 5 p.m. means that 5 hours has elapsed between noon and 5. So I'm going to plug that right into my equation. The number of bacteria is equal to 15,000 e to the 0.3 times 5, because that's how many hours have elapsed. So now I'm going to go to my calculator. I'm going to put in 15,000 times e to the 0.3 times 5. Hit enter, and you get that there are about 67,225. Now, if you wanted to put the decimal, you could, but remember, we can't really have a decimal value for bacteria, so you are just going to say that there is about, so you're going to put a squiggly equals, that's the about, 67,225. Letter B asks, how long will it take for there to be over 120,000 bacteria? So in this case, your bacteria is B. So you're going to put in 120,000 equals 15,000 e to the 0.3 times t. Now there are several ways you could go about solving this equation. You could solve this equation by t by taking the natural log of each side. You could also go into y equals, and you could put in that basic equation of 15,000 e, let's try that again, 15,000 e to the 0.3 t, or 0.3x. Okay, and then when you graph that, it's really not going to show up on your standard graph because it's a natural log. So if you do zoom fit first, just to kind of get a basic starting place for the graph, you can see this is what it's going to look like. Then you could go to the table of values and see when this number here in y is going to be 120,000. Okay, so if you look right here, this is where it goes between 6 and 7 is where it goes to 120,000. So it's going to take 7 hours for it to reach 120,000. Now another way of doing that, so it is definitely 7 hours, is to solve this equation. And to solve this equation, you have to start by dividing both sides by the 15,000. Divide this side also by 15,000. So 120,000 divided by 15,000 is equal to 8. So 8 equals e to the 0.3 t. Now to solve this equation and to get this t by itself, you now have to take the natural log of both sides. So ln of 8 equals ln of e to the 0.3 t. Well, if you remember back to your rules of natural logs, the ln and the e cancel each other out, and I'm left with the ln of 8 equals 0.3 t. Now I can divide both sides by 0.3, and I get that t is equal to the ln of 8 over 3. Now to evaluate that, I'm going to go ln of 8 divided by 0.3. And you'll get that time should be equal to 7, but it's not. Oh shoot. Okay, so when you put this in your calculator, you have to do ln of 8, and you have to close the parenthesis first, and then divide it by 0.3, because you're taking the quantity of ln of 8. And that's when you get that 7 times. 6.9 will round to 7.